Namaste everyone. In this video we will be solving a problem on kinematics. The problem is on a parabolic path, a free falling path. So we have a motorbike. We have to find the velocity with which the motorbike has to leave this surface, which is at 30 degrees angle, so that it's going to land safely over at this side. And so the angle of this also we need to find. Okay, so these are the two things that we're supposed to find. So let's go ahead and solve it. We all know the relation for this particular thing. The relation is given by this particular equation, and in this we will have to feed the coordinates. So the starting point coordinate we will assume it as 0, 0. Both x and y values are 0. The ending point coordinate, which is over here, we will have to assume it we can see from the diagram that downward direction is 2 and forward direction is 6. So x comma y, the coordinates of this point will be 6 comma -2, because in y direction we are coming in downward direction. So these two coordinates we need to feed in our equation, and doing that will give us -2 equals 6 tan of theta. Theta is 30 degrees, and x distance is again 6, so 6 square into 9.81, that is gravitational acceleration. Then 2 times cos square 30, and u square remains here as the unknown that we need to find. Let's go ahead and simplify this. When we feed this complex value here in the calculator, we get 235.44. Be careful while you're feeding it in the calculator. If there is an open bracket here for the angle, you need to close that, and then the complete cos value you need to enclose in a bracket before you put the square value. Fine. So this is how you're going to feed it in the calculator, and the value we're getting is 235.44. So let's put a 235.44, and in the denominator we'll have u square. So let us send this term over to the other side. So if you do that, it's of course going to become positive. Then bring back this term over to this side. So 6 tan 30 plus 2 we're going to get in this side. So now we are interested in finding u square, so u value. So it's going to be okay, 235.44, and then this value comes in denominator. Okay, over here, and we have to take square root of this. So feed it in the calculator, we can see we're getting a value 6.56. so u value is 6.56 meters per second. Once again, a small tip: when you're feeding these values in the calculator, if your calculator is putting an opening bracket for tan in the beginning by default, then you need to put a closing bracket for tan and then add the other value here in the front of it. Okay, so that's giving us our first value, that is u, the velocity with which, the minimum velocity with which this bike needs to leave the platform. Okay, so the next thing we have to find is the angle alpha. How much is the angle alpha, so that it lands smoothly over to this platform. Let's go ahead and do that. So this is going to be easily possible with the help of differentiation. We all know that tan of the angle at any point is going to be equal to dy by dx. Fine. So we just need to find, if you are interested in finding alpha, then we need to find dy by dx from this equation, and then we need to just substitute the coordinates, that is 6 comma -2 into this. So let's go ahead and do that. Fine. So when you do dy by dx from that equation, applying differentiation of both the sides, on the left side we get dy by dx, and on the right side theta is going to be constant, that is the angle at which it is leaving the platform. So we're just going to get tan of theta over here, and minus x. So x, again we need to differentiate, we get actually 2x for this, and whatever is in the bracket is again constant, so we just need to put in those values. G value is 9.81. okay, else let me just keep it as it is for now. Later we'll substitute. So 2 times u square cos square theta. Fine. So this is the value of dy by dx. So we just need to substitute the value of x equal to 6 and x equal to 6 and y equal to -2 into this equation, and that's how we will get the value of tan alpha. So let's go ahead and do that. Theta, of course, value of theta is already calculated. It's actually given, so that is 30. The value of u, the velocity with which it is leaving the platform, we just now calculated, that is 6.56. G is constant, of course. Okay, so all these values you just need to substitute here, and you will be able to find alpha. So we are going to get tan of 30 minus 2 times of x value is 6, and into 9.81 whole divided by 2 times u 6.56 square into cos 30 square of this. So let's find this value. You can see over here I have done the calculation. We are getting the value as minus 1.25. So that is the value of tan alpha. So if you are interested in alpha, you just need to take tan inverse of this value, that is minus 1.25. You're going to get it. So if you want to exactly find this, let's just copy this value, go ahead and take now tan inverse of this. So we are getting an angle of minus 51.26. So minus 51.26 degrees. So why minus? Minus is because if you actually see it from this particular direction, just say it from this direction, the angle is in downward direction, and that's why we are getting a negative value. So this is the angle at which we need to build the other platform so that our bike is going to land smoothly without any shock. So that's it for this video. In the next one we'll take up another problem. See you till then. Bye.